Hey, what's up, everybody? The following is episode 8, part 2 with Ralph Ellis. In this episode, Ralph educates us about the royal cubit and the math that went into the construction of the Great Pyramid, the Bent Pyramid, and the Red Pyramid. According to Ralph, the top half of the Bent Pyramid is an exact copy of the Red Pyramid, and the pyramid builders were using the Pythagorean Theorem 2,000 years before we're told that Pythagoras discovered it. I just finished recording a great episode with the Brothers of the Serpent. We dive into all kinds of topics, including the hardstone vases, the moon, UFOs, and all kinds of good stuff. I also had a great conversation with the founder of the Cosmic Summit, George Howard. We dive into the Younger Dryas, the thunderstorm generator, the vases, and more. The thunderstorm generator is either the solution to our energy crisis or an unfortunate hoax. I've got Johanna James and Billy Carson on the calendar, as well as a couple of surprise guests. But let me know what you guys think of this episode in the comments section, and I really hope you all enjoy the conversation with Ralph Ellis, episode 8, Limitless.
All of this, we've been talking about Egyptian measurement systems. All of this came from my book, Thoth, Architect of the Universe. Now, this is getting quite old now. This was 1996 or 97 when we had this sort of pyramid fever was going on at the time. And I got very interested in the pyramids and the megaliths and everything else. And I think I was just of the opinion that it needed a different viewpoint, which nobody else had been there. And one of the things that I saw immediately was all of the books were looking at these measurements in millimeters or in inches. And this is the Bible, The Complete Pyramids, which is a really good book, I have to say. But it measures all of the pyramids in millimeters or meters, which is fine, but that's not what the Egyptians were using. We come back to the same problem with the vase problem. That's not what the Egyptians were using. How can you find out any mysteries within the pyramids if you're using the wrong units? Because they are meaningless. They come out with meaningless figures, 146 meters. For the height of the Great Pyramid. Yeah, so what does that mean?
Right.
You can't see what they were intending, what the designer was intending, unless you use the right units. And that is the royal cubit that we were talking about, 524 millimeters to the royal cubit. And so the first thing I did in this book was go and measure all of these pyramids in the correct units. And you find some very interesting things, which have never been in any other book. And I have to say, 25 years later, still people are not discussing this to any degree, which I find amazing because there's lots to find. So this is the Red Pyramid down at Dashur. And I don't know if you can see them there. There's two people down the bottom.
Yeah.
That's how big this pyramid is. It's big and it's megalithic, and all of the casing blocks have been taken off. But anyway, that's unfortunate.
Mm-hmm.
And it has a very specific measurement to it, and we'll see that in 1 minute. Next door to this pyramid, we've got this one, which is the Bent Pyramid, and because Egyptologists, historians don't know why this pyramid was made, they say, oh, well, the pyramid was having some cracks inside it, and therefore they had to reduce the angle in the upper portions of this pyramid because it was beginning to crack. And so this is what they had to do. And it's all nonsense, of course, complete nonsense, because they're not measuring these pyramids in the right units, because it's as plain can be what they were trying to do, why this pyramid is actually bent. It's metrological, you might say. It's people having fun with numbers. If you read something like the Talmud, it's written by scribes, by authors, and so they have fun with words. Well, these pyramids were being built by architects, and they have mathematicians, and they have fun with numbers. In fact, I think there's a video channel called that, Fun with Numbers. But this is what they did. It's part of their industry. It's what they were doing. They were having fun with numbers. So on the left, we have the red pyramid. On the right, we've got the bent pyramid. And these are the dimensions if we measure them in Egyptian royal cubits, which they were made in. And you can see they were made in because we end up with whole numbers.
Mm.
So the height is 200. Now I've put TC for the Thoth cubit, but the Thoth cubit is the royal cubit. It's exactly the same. So it's 200 cubits high. It's 420 cubits along the base. So the half base is 210 cubits. And therefore the slope angle, because you can calculate the slope angle very easily, is 290 cubits. It's all in nice whole numbers. More than that, it is the 20, 21, 29 Pythagorean triangle. It's Pythagoras. That's why they made it with these dimensions. So that changes things for a start, because we know now that they knew the Pythagorean triangle system back in this era. This is supposed to be like 4,500 years ago. I think they might be older than that, but there we go. Let's give them that due and say it's 4,500 years ago. These are the Pythagorean numbers, and there's not many of them. These are natural Pythagorean numbers below 100. And these are the only ones there are. So to guess, 345, I've underlined that because that is the dimensions of the second pyramid over at Giza. It's a 345 triangle, which is Pythagorean. But to guess 21, 21, 29 is difficult. It's about 1 in 10,000 to be able to guess those three numbers together are Pythagorean. And yet the designer obviously knew this. And I think it's pretty obvious that they understood the Pythagorean constant, as it were, system. But the difficult thing and the tricky thing is, and the mysteries are always contained in the tricky things. You've got to sort of look at those as well as the simple things. Why is the bent pyramid bent, and why is it not Pythagorean? So the first interesting thing about the bent pyramid is it's exactly the same height as the red pyramid. So effectively, it's the red pyramid with the sides chopped down a little bit.
Mm.
And that's why it's bent.
Mm-hmm.
So if it had been the full pyramid, it would have been 420 cubits wide along the base, but it's actually 360 cubits wide along the base. So it's similar, but not the same as the red pyramid. So why is it like that? Well, that's the Pythagorean numbers again. Well, this is the bent pyramid if we look at it in cubits, because we know they were using cubits. And so the bit I was interested in, because, we've seen the whole of the bent pyramid. The bit I was interested in is the top, because effectively we've got two different pyramids here. We've got a pyramid with this slope, which only goes half the way up. Mm-hmm. And then on top, we've got a pyramid with this slope, which is almost like a separate pyramid. And it so happens that this pyramid is the same angles as the red pyramid next door, but it has slightly reduced dimensions, of course, because it's smaller. And it's smaller in exactly a 10 to 5.5 ratio. So if we look at the dimensions, 210, if we look up here on the left, 210 divided by 10 multiplied by 5.5 is 115.5, which is the width of half the base. On the slope angle, 290 divided by 10 multiplied by 5.5 is 159.5. It's in a 10 to 5.5 ratio. Why 5.5? Well, because that's a pi number. And it's used in metrology even today. The imperial rod for the imperial system in America, the rod unit is 5.5 yards. The Egyptians were using 5.5 cubits in exactly the same fashion. We will see why in a minute. So there's a good reason for using 5.5, and it's also a quarter of pi. Remember, the fractional equivalent of pi is 22 over 7. A quarter of that is 5.5 over 7. This is where the number 5.5 comes from. It's a pi figure. Anyway, so we end up with this little pyramid on the top here, which is a smaller copy almost of the red pyramid next door. But these units, well, when I came across these initially, they're all a bit odd, really, aren't they? 159.5. Who would want who would want a figure of 159.5 in their wonderful diagram? Because obviously this was all laid out in some big, draftsman's drawing board, and you'd have it all laid out, on a piece of papyrus or whatever they were using. That's terribly unsatisfactory. Why on earth would you want these odd figures? Well, we have to be using the right units, same as with the vases. You've got to use the right units. And the units they were using was the rod. So if we divide all of these numbers by 5.5 to achieve the Egyptian rod, we end up with this.
Wow.
Those exact same numbers we had before, we just divide by 5.5 and we get 20, 21, 29, which is the Pythagorean triangle. 20, 21, 29 Pythagorean triangle, which is exactly the same size or dimensions, as it were, of the red pyramid next door. It's exactly the same. So as we saw, the red pyramid is 20, 21, 29, if you divide them all by 10, in cubit lengths. And now, for the upper portions of the bent pyramid, we get 20, 21, 29. It's a Pythagorean triangle. So, and I've got the calculations here on the left. So 159.5 divided by 5.5 is 29, etc., etc., etc.
And so just real, the traditional Egyptology does not credit the Egyptians in 2500 BC, 4500 years ago, with understanding the Pythagorean theorem. Is that correct?
That is pretty much correct, because, if you read the complete pyramids, never mentions it.
Right.
It never even mentions pi, because the Great Pyramid is a pi pyramid, which we will probably see in a minute as well. But yeah, they never mention Pythagoras, right, even for the second pyramid.
Right, and the Greeks are essentially credited with beginning through Pythagoras with beginning advanced understanding of advanced geometry and the Pythagorean theorem. And the question now, Pythagoras spent a couple of months in Egypt, and then he came back to Greece, and he created this school of ancient sacred geometry and a religion, that it was very unique for at the time. He was obviously an incredibly intelligent person, but I guess the question is, did he get that from the Egyptians, and did the Egyptians have this knowledge long in advance of when we credit them for having it? And certainly appears, based on your research here, that certainly the Egyptians were, or whoever created these pyramids, were understanding the Pythagorean theorem and advanced geometry.
Yeah, and they're displaying it for everybody to see.
Right.
I mean, this is the whole idea, isn't it? The designer wants to show off their knowledge. of mathematics and architecture. They do it sometimes in modern architecture as well, where they design in things which are not essential for a building, but it's something interesting that they add into a construction to make it more interesting. I think they were doing this because they wanted people to know that this was a technical civilization that built these pyramids. And how do you do that? How do you display to ordinary people without having to go down to the micro level of looking at everything within this pyramid, that this is a high-tech pyramid? It's not just stones piled on top of each other until they reached a peak, that there was some cognitive design behind it. Well, the easiest way you can do that is to involve mathematical constants like pi. And of course, the Great Pyramid is based upon pi. In fact, more than that, it's based upon a circle, 2 pi r. So we have a recognized mathematical formula in the design of the Great Pyramid. And then if you look at the second pyramid, we get a 3, 4, 5 Pythagorean triangle. And some people have said, well, you could guess that one, it's not very difficult. You can guess 3, 4, 5. Okay, but now we go down to Dashur and we've got 20, 21, 29. That's a difficult one. You can't guess that one.
Right.
And it's a sure sign to anyone like myself coming along in later eras that there is some mystery, mathematical mystery here. And perhaps if you look closer, you will find something interesting. And we do. And we will look at what we can find later, because it gets very esoteric. It goes off on a big tangent way up into the Himalaya, which is quite fun. But you would never go along that route, finding out all of these minor mysteries, as it were, if you didn't know that there was something technical to start with. So I think it's just an illustration of the prowess of the designer. This is what I know. This is what I understand. Come and look within, because you will find more secrets. Look upon my works and be amazed. What was that from Ozymandias?
Yeah. Uh-huh.
Yeah, look upon my works and be amazed, or something of that nature. And that's what they wanted you to do. They wanted you to look upon these works. And also it's an invitation, because we find this up at the Great Pyramid as well. It's an invitation. You find that the exterior is based upon pi. And you think, wow, that's interesting. What else can I find? And so then you go hunting for all of the other possibilities that you might find. So it's very much an invitation. Come and see what I hold within.
Right.
And that's part of the reason they did it. But the other thing is, we can now for certain say that this was designed from day one. This was not a change of plan, that they were going to change the orientation of the top of this pyramid because of some cracking and some subsidence or whatever they say. That's all hogwash. This was the design from day one. They wanted a smaller version of the Red Pyramid stuck on top of the Bent Pyramid in a 10 to 5.5 ratio, so that you know that these two projects are linked in some manner. They're part of the same design.
Yeah.
What that is, we don't know. I postulated, and of course it is based on not very much at all, because we don't have the information. I think this is a layout on a planisphere, that there was a bit of a as above, so below, the old Masonic adage that what is you can see in the heavens can be reflected on Earth. And basically they were drawing a planisphere, with the Giza pyramids being the belt of Orion, as everybody knows. And then if you go out from the belt of Orion towards the the northern heavens, the center of the planisphere, you will find two poles, the celestial pole and the ecliptic pole, which rotate around us. This is what the Greeks called the two wheels of the cosmic cart, because it looked like two wheels rotating around each other. Because they rotate around the celestial pole and the ecliptic pole, they rotate. I think they were pointing out these two pyramids as being poles, one being the celestial pole and the other one being the ecliptic pole, in a vast projection of the cosmos on Earth, as above, so below. And that's useful because you can use it for dating. I've used that design for dating because these two poles rotate around each other. If you know their position, then you can get a date from that. And the date I got was, I think it was about 14,000 years ago. Anyway, we'll look at something similar in a minute. But yes, you can actually get a date from the position of these two poles.
Interesting.
So I think that's possibly what they were doing because, people have been doing this. This has been part of religious experience for thousands of years. They are still doing this now at Mecca. If you go to Mecca, if you do the Hajj and you go into the Grand Mosque, you've got the Kaaba in the center, and then all of the faithful rotate around the Kaaba. What are they doing? Well, if you look at it from above, it's quite obvious that they are the stars in the heavens above rotating around the celestial pole. Because they're drawing out exactly what you would say if you look upwards at the celestial pole, if you look at the North Star, Polaris, and watch or better still, get a camera and take a long exposure, you will see all of the stars rotating around Polaris. Well, that's what they're doing. All of the faithful are rotating around the Kaaba, and they draw the same image on the earth, as above, so below. They are recreating the cosmos within the mosque. But don't tell Muslims that because they wouldn't appreciate it. But there we go. That's exactly what they're doing. And we've got an idea that this was common because they had the same down in Saba, which is now modern Yemen, where the temple of Bilqis, Bilqis is the queen of Sheba, had exactly the same. They had a Kaaba down there. So they had a big oval circular temple with something in the center, which was obviously the same as the Meccan temple, where people used to walk around it and rotate around it, imitating the stars rotating around the celestial pole. And at Dashur, you could do exactly the same. So my postulation is they were doing exactly the same as a ceremony down at Dashur thousands of years ago, because you couldn't do this at Giza because there are too many artifacts around it. There's all the big necropolis and the causeways and all sorts of obstacles in between. You can't do that at Giza. But down at Dashur, these pyramids are out in the open. You could indeed have a ceremony where everybody is rotating around these pyramids and recreating the cosmos on the earth down below. And I think that's what they were doing.
So, Ralph, on the pyramids themselves, you had mentioned that when you look at them and you think about a date at which they possibly could have been constructed. I'm curious. I know you mentioned 14,000 years ago as a potential possibility, but what are your thoughts in terms of when those two pyramids specifically would have been constructed?
Yeah, this comes on to my pyramid work, which I went back to when I had more information, and looking at stellar possibilities again. Alignments with certain constellations and the pattern of the cosmos as it rotates around each other. And one of those rotations is the precession of the equinox. Now, this has been written about by many people. Graham Hancock wrote about it, of course, in Fingerprints of the Gods, which I found very interesting, of course, back in the 1990s. And the idea there was that This is the Sphinx looking eastwards. This is at Giza, of course. And the Sphinx looks due east. And the Sphinx could quite obviously be interpreted as an image of Leo. And what happens with precession, it turns the heavens around if you look at the North Pole, but also the constellation that rises at the vernal equinox, the spring equinox, will change every 2,200 years, roughly. That's on average. Some of them are a bit longer and some of them are a bit shorter. But this was well known about in ancient times. It was known as the Great Year. So we have the normal year, the annual year, but we also have a great year, which is about 2,000 years long. And you can track this by looking at which constellation is coming over the horizon at the vernal equinox, the spring equinox. And this is what people thought that the Sphinx was doing. It was looking for itself coming over the horizon at the vernal equinox. Now, that only happens in a certain date. This is how we can get celestial dating from these monuments. And of course, the idea was, and you can see my cursor going around, that this happened in 12,500 years ago, 10,500 BC. Now, in my calculations, it's not so clear cut because Leo is quite a big constellation. Mm-hmm. So we enter Leo at 10,000 years ago, and we exit 12,500 years ago, with an average of about 11,250 years ago. The idea being that if you're building this huge, great monument and you want to date it for future usage, to say to people in the future, I was here. This is when we built this marvelous monument. This is the mathematics I understood at this time. You would align your monument to line up maybe with precession, with Leo looking at itself coming over the horizon. And this would date the Giza pyramids to about 11,000 years ago. Now, this conflicts with the modern carbon-14 dating that they've been doing recently, because they've been finding little bits of datable material within the mortar of the Great Pyramid. And they dated a piece of wood that might have been original to the pyramid when it was constructed, that came out of one of the shafts.
In the Great Pyramid?
Yeah, in the Great Pyramid. When the Queen's shaft was opened by Wayman Dixon back in the 19th century, a piece of wood fell out, which was a measuring stick. And so he packed that. There was also a ball and a hook, and he packed up these items, sent them back to England. This was in the 19th century, and they went missing. And they were found about 5 years ago in a museum in Edinburgh. And so someone decided to date this piece of wood, and it came out with something like 5,000 years ago, which conflicts with all of this celestial dating. So I don't quite know what to make of this, because their carbon-14 dating is very conveniently the same as the classical dating of the pyramids.
Right.
Whereas all of this celestial dating all points towards a much older era. So we're not quite sure which is the more correct at present. More work is going to be needed on this. Yep. But what happens is with this celestial dating, and there's two methods of doing this celestial dating. You can do it via the Sphinx, looking at the horizon, and you can also do it with Dashur being the ecliptic pole and the celestial pole, with them rotating around each other, and they come out with the same date. So the celestial dating of as above, so below, the planisphere of Giza, you might say, gives the same date as this, as the Sphinx dating, which is interesting. But But we can take these dates back further if we want, because this is a cycle. The precessional cycle is a cycle which goes around in 26,000 years, and it starts again. So the Sphinx might be looking at Leo 11,000 years ago, but he would have done the same before. And so if we look at this graph, this is a graph of precession of the equinox, zeroed for the time of Leo, because obviously it changes as the constellations go round and round and round. So this is a graph for precession of Leo at Giza. And this has been calculated by Professor Pierre Lascar, French astronomer, who's calculated precession for the previous 25 million years. So this is a very, very predictable pattern that goes round and round and round. It does change very slightly, so it's a very, very difficult calculation. It's because it's affected by Jupiter, who makes perturbations on our orbit as it goes around, because Jupiter is quite big. So it does change very slightly each cycle. But anyway, you end up with this cycle. And we've got degrees of precession on the left. And obviously, when it gets to 360, or rather when it gets to 0 degrees, it flips to 360, of course, as you go around a circle. That's why we end up with a sawtooth pattern. So today's date, the dates are down the bottom. 0 date, that's today's date, is up here, obviously not pointing at Leo at all. These points that I circled here are when Leo, when the Sphinx can look at Leo itself coming over the horizon. And of course, it's a cycle. This is the 12,000 years ago cycle.
Right at the Younger Dryas.
Right at the spot on the Younger Dryas, which is again very interesting.
Yeah.
Who's that chap who does all of the geology? Talks about this quite a lot. I'll remember his name in a minute. Quite a famous guy. But this pattern goes back.
Randall Carlson.
Randall Carlson, yeah. Mm-hmm. Well worth watching some of his videos on this topic, and what might have happened during the Younger Dryas, whether there was a cometary impact or something of that nature.
Right.
I've got a video and an article I did myself on that as well, because I think Carlson is probably correct that there was an impact at this stage. On this particular diagram of the graph of the precession of the equinox, the cycle repeats. And so you can have the Sphinx looking at Leo at 12,000 years ago, 38,000 years ago, 64,000 years ago, or 88, 90,000 years ago. So you can take your pick. You can go as far back as you like. So depending on how long you think a pyramid could last before it gets weathered away, the celestial alignment confers with those dates. So, but we have no way of choosing between which cycle they could be. Right. So you can push the date for the Giza Plateau back thousands of years if you wish. So yeah, that was an interesting finding.
For sure.
We were going to have a look at the pyramids, because now, armed with this extra information I had from Stonehenge and Avebury, because we can do exactly the same with Stonehenge, we can get lines of latitude and longitude out of Stonehenge as well. It was pretty obvious that the designer of these megaliths understood a lot more than classical history would give them credit for. Maybe we could find the same down in Giza. And boy, yes, did I find the same or not? And this is where we go off on a real tangent. I mean, we've been off on some pretty good tangents already.
Love it.
This is where we really set fire to it. You have to understand from this that the designer had intimate knowledge, as good as we have today, of these technical subjects. And just as a by the by, we were talking about pyramid mathematics before. The Great Pyramid has the same as Dashur. It has little mathematical secrets as well. So the Great Pyramid, this is the Great Pyramid on the right side here, is a 40 times copy of pi. So the little pyramid on the left is my image of pi. Pi, using the fractional approximation, is 22/7. So the pi pyramid is 7 units high, 11 across the base, or half of 22, of course. And that's the sort of prototype we're going to use to build the Great Pyramid, 7 by 11. If you multiply those two by 40, you get the dimensions of the Great Pyramid, which is 280 high and 440 across the base, exactly 40 times greater. And remember the 280, the finger unit we were looking at before is 28 fingers. And now we have 28 for the height of the Great Pyramid, 280. Why do we have these figures? Well, because they're all connected with pi, of course. In the smaller version, it's 7. Multiply by 40, it's 280. You do the same in the measurement system. 7 by 4 fingers is 28 fingers. That's important, and I only thought about this much later, so this is not even in the books. It rather implies that the measurement system we were looking at of cubits and fingers was designed for the pyramid. It did not pre-exist the pyramid. They could have had any units for this measurement system. They could have had, decimal or centennial, any sort of measurement. But no, the measurement system they've got matches the design of the pyramids. And so to me, this suggests that the measurement system was made for this construction project. And with it, they built the Great Pyramid. So any Egyptian artifact that uses the royal cubit must post-date the construction of the Great Pyramid, because the meteorological system was made for the Great Pyramid. And that's interesting, because it can change the dates of some artifacts. The other thing is that we're still using the same measurements today, or you are in America. So this is not generally known, and I don't know why. The Great Pyramid perimeter length is 1,760 cubits, royal cubits. And of course, the imperial mile is 1,760 yards. We're still using the same measurement system as they were using to make the Great Pyramid. Now, the yard is not the same as the cubit, so the actual length of the mile is different, but all of the fundamental functions of this measurement system are still being used today. So the furlong, the Egyptian furlong, was 220 cubits. The furlong used in horse racing, horses raced by the furlong. Nowadays, it's 220 yards, of course, but it's based on the same system. Why is it 220? Well, because it's based on pi, of course. Pi is 22/7. Multiply that by 10, you get 220. That's how the system was devised. The Egyptian chain was 22 cubits. Why 22? Well, because it's based on pi, 22/7. And we still use the same today. Now, even in Britain, although we're metric, if you measure a cricket pitch is one chain, or 22 yards. Hasn't changed. It's not measured in meters. It's measured in yards. So again, that's the same. And then we come to the rod system. So we looked at the rod before, this very peculiar unit of 5.5. Why is it 5.5 yards to the rod in imperial measures, or 5.5 cubits? Well, because it's a quarter of 22, of course. So again, it's a pi-based system. And that explains all of the imperial measurement system. I've read several books on measurements, and they say that this 5.5 is a very strange unit, and therefore it's a conjunction of two different units that where they met together, they ended up with this strange 5.5. No, it's just a quarter of pi. You can explain the whole measurement system just by using pi. So that is why America still has the imperial system, because it's a sacred system. It was the system that was used to build the Great Pyramid, and it's still in use today. Pi is an irrational number that has decimals that go into the millions. It's never ending. Right. So there is no fraction of pi. All you can get is the nearest whole number fractional, and that has been 22/7 as being the closest easy fraction.
That's 22 divided by 7 is 3.14.
Yeah.
Yeah, got it.
And the reason for that is that if you're building a building like the pyramid, you want the height and the base length all to be in whole numbers. If you use proper pi, you'd end up with fractions all over the place. And, that's just not convenient.
Mm-hmm.
So rather than doing that, let's use the fractional equivalent of pi, which is 22/7. And then everything ends up in whole numbers. It's not quite pi, but it's good enough, And also, I don't think I mentioned it before, the pyramid itself is actually an image of a circle. It's 2 pi r. So it's not just pi, it's twice around the base. And so therefore, it's an image of a circle. So it is a circle squared. You've heard of the adage of squaring the circle. The Great Pyramid is a circle squared because mathematically it is a circle. But when you look at it, it's got a square base. So it is a circle squared. And yeah, that's just, one of the little interesting snippets you get from the Great Pyramid. I was going to say something else about that as well. Oh, yes, it's an Earth-based Earth-based measurement system. So we still use this measurement system today. We call it the nautical mile. So a nautical mile is 360 times 60. This is looking around. The nautical mile is based on the size of the Earth. So you get 360 degrees times 60 to make it into minutes. And so that comes out at 21,600 nautical miles for the circumference of the Earth. That's how the nautical mile was devised. And we still use the nautical mile. If you're in aviation or in maritime services, aircraft all fly on knots, which is 1 nautical mile per hour. So we still use that same system now. So the Great Pyramid is half a nautical mile in circumference. It is an Earth-based system. So again, we have an indication that the designer of the Great Pyramid knew the circumference of the Earth and made the Great Pyramid accordingly. Oh, and in terms of latitudes, we were talking about latitudes for Avebury. The Great Pyramid sits on the 30-degree parallel north, again indicating that the designer understood the latitude system for dividing up the Earth, because it's on a very particular latitude north. The next thing I was going to talk about was the shafts.
And how does the 43,200, is that worth also explaining, as long as we're talking about the pyramid and the numbers? 43,200, that number embedded in the pyramid as it relates to the size of the Earth?
Yes, Graham Hancock and various others have highlighted that figure, that the Great Pyramid is 143,200 200th of the diameter of not the diameter, the circumference of the Earth, which is all very interesting. But they didn't explain, I think, very well where that number came from. I didn't find their explanation very satisfactory. Well, it's half a nautical mile. So in nautical miles, we get 21, if I can line it up, 21,600 If we multiply by 2, we get the 43,200. Mm-hmm. And that's where it comes from. That's where that figure comes from. It's 1/2 a nautical mile. So again, yes, the Great Pyramid is an Earth-based measurement system. So the perimeter length of the Great Pyramid would be 1 Egyptian mile. I'm pretty sure that's what they would have used for any measurement systems if they were measuring, the distance between Karnak and Giza or something. They would use the Egyptian mile, which is 1/2 a nautical mile.
And if you multiplying the perimeter of the Great Pyramid by 43,200, you get the perimeter of the Earth at the equator, and multiplying the polar circumference of the pyramid by 43,200. So the north and the up and down, the vertical circumference of the pyramid by 43,200, you get the polar circumference of the Earth, is my understanding.
Yeah, they're slightly different because the Earth bulges out at the center, but they are very, very close. And the pyramid does match them very closely as being 1/2 a nautical mile. If I remember correctly, the nautical mile was made for the equatorial circumference, not for the polar circumference.
Okay.
I think because they were trying to measure latitudes, distances along the latitude more than they were the polar sort of dimensions. And so I think the nautical mile is the equatorial dimension. But there's not too much within them, in terms of decimal points. Is that they're very close.
Yeah. All right.
The next thing I was going to talk about was the shafts. People who follow the pyramids will know the shafts that come out of the King's Chamber in the Great Pyramid. So this is one of the shafts. It's not very big. It's only in imperial terms, it's only about, 8 inches wide or something. They're quite small. They're obviously not used by people. And they have no function. Some people, I think, Clive Dunn suggested they would be part of a chemical experiment, but these shafts are not accurate enough to hold any gases or liquids. There's too many gaps in them. As you can see, some of them are quite rough. This is one of not Van Danken, one of the other German chaps who did the exploration of the shafts. He said this was a Monday morning shaft, where you can see it's all been broken off at the base. Although the general direction of these shafts is quite accurate, the actual construction of these shafts is not that accurate in places. He suggested there were eras when the designer was not on site. And so the workers skimped and didn't do exactly as they were told. And there was various rough sections in these shafts going all the way up inside the pyramid. So I don't think they can be used for liquids or gases or anything like that. They're just a small shaft with no known function, because the queen shafts do not poke out the side of the pyramid and they don't poke into the chamber. So you can't really use them for star shaft pointing, as someone will look at that in 1 minute. And Gantenbrink, that was the German guy I wanted to remember. He was the guy who sent the first of the robots up there. Mm-hmm. And he said these little shafts increase the building time of the Great Pyramid by at least a factor of 2.
Wow.
Because they're so difficult to make. Now, you can see the stone in these shafts follows the shaft angle going upwards. But you cannot do that in a pyramid all the way up the shaft, because you'll end up with a weak point where all of these stones together can end up like a train, with all of the carriages on a train on a railway track, and they'll all just, if you put a railway track on a slope, all of the carriages will just zoom off down the track. And these stones will do exactly the same. They'll all gang up together because they're at 45 degrees angle, and they'll just all charge straight down and end up in the king's chamber. So architecturally, you cannot do this. And so I don't know what it is, every 15 meters or so, they have to put a girdle stone in, which is a huge, great stone with the shaft going through the stone in order to tie all of this shaft into the rest of the structure of the pyramid, to stop this shaft, the weight of this shaft, ending up with all of these stones inside the king's chamber or the queen's chamber. So these are very technical, and they curve as well, left and right a little bit, to get around the grand gallery. These are very technical little shafts. They are highly important because they're so difficult to build, and yet they have no known function. Mm-hmm. And at the end of them, you end up with these doors or blocked areas with these two, I think these are pure copper.
Copper, right? Yeah. Ganson Brink's door.
Yeah, like handles. And I would like to know what happened to this one. The end of this one, when they first went up there with Gantenbrink, was sitting on the floor. It was down here. And then they went up the second time and it wasn't there.
Right.
So someone must have the end of this handle, which would be interesting. Yeah, he's probably got it, stuck on his desk maybe as an ornament. I don't know, paperweight. But it would be very interesting to analyze it, because knowing the isotopes perhaps within the copper, you might be able to suggest how pure it is, where it's come from, all sorts of other things, how it was processed, by the impurities in it. You can tell a lot about the manufacturing process. It would be nice to know what happened to that, the end of that handle.
Yeah, we probably know. But how did it erode is the question. It looks like it eroded from the bottom, like those copper pins eroded from the bottom. I had Chris Dunn talking about his theory on the podcast last month, and he his theory is interesting. We don't need to get into it, of course, but it does look like erosion of copper from the bottom up, which so.
We don't know if they were shaped like this originally, or whether that's just all pure erosion, or maybe they were tapered to start with. Certainly there's a lot of erosion on them. But a proper analysis of these sort of handle artifacts would be interesting. And of course, we don't know what they are. We're calling them handles, but we've got no idea what they are. They could be anything. I've got no rationale, even with my ideas on this. I have a very different idea, of course, to Chris Dunn, but my explanation gives no inclination as to what these could be, why they're there. No idea.
Okay.
But what I know that these things are not is they're not star pointers. So this idea came out by Robert Beall, and I think he's totally wrong on this. He said that these are star pointers. Again, you cannot do that by looking up these shafts, because they're curved, and so you can't see up them. And the Queen's chamber shafts were never cut into the chamber, and they don't protrude out into the outside air either. So they're completely blanked off at the far end with those doors. And they didn't protrude into the Queen's chamber. This is the Queen's chamber down below, because they were concealed, and they weren't found until, I think it was Wayman Dixon was prodding along in the Queen's chamber, because he knew that there were shafts in the King's chamber. So he was tapping along, trying to see if there's any shafts in the Queen's chamber. And he heard a different note as he was tapping the stone. And so he stuck in a piece of wire, and it just kept on going and going and going. So he knew there must be something there. So he cut open the holes that we see today. And lo and behold, there was another shaft. And so we ended up with 4 shafts. And it was proposed that these shafts are supposed to point at stars. They're star pointers, which is interesting because if we have a star pointer, we can possibly get a date. And the date, of course, that they are achieved is very much the classical date. It's like 4,500 years ago. And this is the diagram that you will always see. You will see this in history books now, classical history books. And they'll put up this as proof that these pyramids were built during the Old Kingdom. And therefore, they're only 4,500 years old. But it's not exactly like this because these two shafts don't point at Orion and Sirius at the same time. They point at Orion, and then 4 months later, Sirius comes along, and then it points at Sirius. So it's not simultaneous like it's shown in this diagram. There's 4 months between them. And then when we look at the northern shafts, there is nothing up in the northern heavens, even accounting for precession, because of course these northern stars will change. It wasn't Polaris as being the northern star in this era. But even if you look at 4,500 years ago in that particular location, there was no particular stars that they were pointing at. So these northern shafts have no known reason. And I think I can prove that these are not star pointers, because if we look at the angles, here's an image of all of the angles. And so these are the shafts: King South, Queen's North, King's North. The angles are 45, 39.5, 39.5, 32.5. Now, the difference between these shaft angles.
And so south is to the left on this diagram?
Yes, sorry, yes. That's south on the left side, and north. The entrance to the pyramid is on the north side. So, yeah, these are the northern shafts.
Okay.
The difference between these shafts in angle terms is 5.5 and 7. Familiar numbers. We've already been looking at this. These are pi numbers. So 5.5 is a quarter of 22. And the fractional approximation of pi is 22 over 7. So we get a quarter of a pi. 5.5 over 7 is a quarter of pi. And the trouble is, if we're looking at star pointers, if the angles of these shafts have been fixed by pi, by a mathematical constant, they no longer have the latitude to point at a particular star on a particular date. Because say you build this pyramid 10,000 years ago, well, you can't point at Orion with a pi shaft, because that's not the angle that Orion will be in. Because remember, Orion and Sirius, these stars go up and down with precession. So they will change. But if your shaft angle is fixed at 45 degrees, it can no longer point at Orion. It cannot be a star pointer. It's fixed for another reason. And what is that other reason? Well, what can you use a angle for? Well, you can use it for pointing at stars, perhaps, but what else can you use an angle for? Well, if we've been talking about form of the Earth, latitudes and longitudes, perhaps we have latitudes and longitudes here?
Nice. Yeah. So if people want to, follow your work, then, obviously the books that you've written, you mentioned Thoth, you mentioned K2. I know that you mentioned your Facebook page. You also have a YouTube page, although it looks like maybe it's been about maybe a year or so since you've downloaded new content onto there.
I've been busy doing other things. Yes. So the Facebook page is ralph.ellis.144, and that will find you the Facebook page. The YouTube is just Ralph Ellis. I think YouTube Ralph Ellis, and it'll go and find it. So what you're looking for is a thumbnail that has a red and gold phoenix on it, and that'll be my YouTube. I've got a website which is Edfu Books, so EDFU pythagoreanbooks.com, and that'll go and find my website. There's not much on the website because I find it very, very difficult to update it. So I do all the updates on Facebook instead. But it has all the information about the books there, which is interesting. So you can see all the books.
Nice. Excellent.
Yeah. So yeah, I've been busy, but
yeah,
it's I've been doing a lot more interviews now. So that's why my YouTube channel has suffered somewhat. I'm doing an awful lot of YouTube, mostly YouTube videos with other people, a few podcasts and various other things.
Nice. Yeah, it's incredible content. It's very extraordinarily thought-provoking. You've given myself and everybody else a lot to think about and a lot to consider and a lot to digest. And so thank you. Thank you for the work that you've been doing. It's again very, very thought-provoking. I would love to have you on again in the future at some point. With however many hundreds of pages on Facebook. I'm sure there's a tremendous amount of other topics that we could probably dive into. But
indeed.
Yeah,
I'm sure we could find some interesting topics. And thank you for yourself and the rest of the team in discovering these new ancient vases, because I think that's going to add to the many mysteries that we've already got, and hopefully explain some as well, because that it's part of the same puzzle.
Yep.
I call this a huge, great historical jigsaw puzzle.
Yep.
And slowly we're putting all of the pieces into this jigsaw puzzle. And luckily, most of them join up and actually start to make a proper cohesive picture. So it's a jigsaw puzzle that works. Unlike the critics who just like to try and tear things down, we're actually making a recognizable pattern of ancient history that does actually work. It means you have to sacrifice some of the classical ideas, but apart from that, it works very well. It's very cohesive.
Yep. Yeah, well said, and completely agree. And again, just really appreciate you coming on the show. And with that, I think that's essentially a wrap. I think so. Yeah, really appreciate everything, Ralph. It's great to chat with you.
Thank you.